Welcome to the lecture series on applied chemistry. Here we discuss Zinc-Air Battery. In the series, we are discussing what are the batteries, what are the types of batteries, and lithium-ion battery. Now here we discuss Zinc-Air Battery. What are the characters of a Zinc-Air Battery? The metal, that is zinc, and air batteries cells uses a technology and energized only with the atmospheric oxygen. When the atmospheric oxygen is absorbed into the electrolyte through a gas permeable liquid tight membrane. With the removal of a sealing tab, oxygen from the air is introduced into the cell. A Zinc-Air battery usually reaches full operating voltages within 5 seconds of being unsealed. That means once it is unsealed, the air gets into the system and it undergoes a reaction producing energy. The zinc air cell is basically a primary battery. It is a non-rechargeable one. However, the rechargeable designs for high-powered applications are possible by physically replacing the zinc electrode. They use the oxygen content of the air as an active mass. So the positive electrode, that is cathode, is a porous body made up of a carbon which air accesses. The air means that is an atmospheric oxygen is reduced at this electrode. You see the typical diagram in which the anode, the negative charge which holds a zinc, and the cathode which where in which the oxygen enters, and the zinc undergoing an oxidation, and it produces an electron, and the electron is transferred from the zinc to a cathode where the oxygen is undergoing a reduction process. So atmospheric oxygen is reduced at this electrode. Here the active mass is that not contained in an electrode, but it taken from the surrounding. So the advantage, the main advantage is the electrode in which the oxygen is taken up from the atmosphere that is surrounding. So it won't produce any much cost. So the initial weight of the battery is also reduced due to this process. And the negative electrode, that is anode, consists of zinc, which are undergoing an anode reaction. The reaction is given here, zinc plus half amount of oxygen produce a zinc oxide, or 2 times multiplied by this for the balance 2 ZnO. And zinc in the go is an anode and atmospheric oxygen as a cathode. And in between it, the electrolyte, that is potassium hydroxide, is being paired. The aqueous solution of potassium hydroxide serves as an electrolyte. So the cell voltage for this theoretically is 1.65, but almost the design has been optimized for the practical application. Gives between 1.4 to or 1.3 volts to achieve a longer lifetime. When we increase the capacity, the lifetime gets reduced. That becomes a disadvantage of this. And here is the three-dimensional cross-sectional diagram and this anode cathode reactions. So anode is a zinc, cathode is an oxygen atom, and electrolyte is a potassium hydroxide. Zinc-Air battery, we call it as modern battery because it's a lightweight and uses atmospheric oxygen and offers a high energy density. And the diagram is given, and the typical cell representation is zinc, KOH, C, and R. The overall reaction, anode reaction, which zinc undergoes oxidation and combines with the hydroxide ion from the potassium hydroxide, produces zinc oxide, water, and electrons. The electrons taken by the oxygen and water, and again it reproduces 2OH, so that potassium hydroxide electrolyte get balanced. Only oxygen is undergoing a reduction reaction, and the overall reaction is found to be zinc plus oxygen gives zinc oxide. The advantages of these batteries are it's a high energy density. but power is somewhat low. Inexpensive because it uses atmospheric oxygen. Gin gas system, when sealed, has an excellent lifetime, with the self-discharge rate is very, very less. Usually, primary batteries has more self-discharge rate, but it is very, very less for Zinc-Air Battery. In relation to the physical size, Zinc-Air Battery store more energy per unit of weight with almost any other primary type. Primary cells available in this range of button, the cells or shape is available in many ranges from a button to the coin size and to the battery size, etc. And nowadays, rechargeable high power cells are available, but somewhat it is difficult to produce high power in that due to its reversible reaction capacity. So from this, we can go through this question. Which of the following is an advantage of alkaline battery? High energy density is a major advantage. And a cheap raw material we can use because oxygen is being used. In voltaic cell, anode cathode of a cell is the voltaic cell anode is always found to be zinc and cathode is found to be a copper. EMF of a dry cell is found to be 1.5 volt. Secondary cells, in which are the facts are secondary cells? That is, lead acid battery secondary cell, it can be recharged. Alkaline battery cannot be recharged. And the A alone is correct because that is only a secondary battery there. In cell, the current flows in outer circuit from negative terminal to a positive terminal. So in this session, we discussed about what is a modern battery and in which we took an example of Zinc-Air battery and what are the anode and cathode of Zinc-Air battery which use atmospheric oxygen. And we have discussed the advantages of these batteries and cell reactions and a few more MCQs to understand the concept. Thank you.